Hi guys, welcome to another STL video, and this video is all about sets and multisets. All the containers that we have discussed so far, that is vectors, lists and forward lists, are all sequential containers, which means that we can access the elements in those containers sequentially. Sets and multisets are the first associative containers that we are going to discuss. Obviously, we can't access the elements in them sequentially. They have another constant on them. To understand that, let's first see how sets and multisets are internally implemented. Internally, sets and multisets are nothing but self-balancing binary search trees. To explain it in very simple terms, basically, as you keep inserting elements in a set or a multiset, a binary search tree is formed. And thus, all the elements in a set or multiset get sorted by themselves. And this is the main features of both sets and multisets. So, whenever sets or multisets come into picture, you should picture a tree being formed. Another point to note is that in sequential containers like vectors, we can access the elements by index. But here, since there is a tree and there is no sequence as such, we cannot access the elements by index in sets or multisets. Another point to be noted is that we cannot modify an element. If we want to change an element, we should first erase it and push another element with a new value in it. Why is that the case? Since a tree is self-balanced, if you change the value of a key, then the balancing gets destroyed. And how will the tree come to know that, okay, I have to balance? The tree balances only when you are inserting an element. That is why you cannot modify an element in a set or a multiset. Now, if elements are sorted in both sets and multisets, what is the difference between them? The difference is that in sets, only distinct elements are allowed. But in multisets, same element can be inserted again and again. In set, if you insert the same element again and again, it will be discarded. That means, say if I insert 2 4 times in an empty set and in an empty multiset, and that is I do s dot insert 2, s dot insert 2, s dot insert 2, s dot insert 2, the size of set after that will still be 1. But the size of multiset will become 4. That is why if we count any element in a set or a multiset, the counter in case of set can always be either 0 or 1. But in a multiset, the count can be any non-negative number. Now, let's see how to define sets. Just like vectors or lists, we can just write set of integers. Since again this is a templated class, so we have to mention which data type we want to use. So right now I have taken it integer, so I can just write set int s. So right now there are no elements and then we can insert the elements later. Or we can also define a set just like array. So I could have written it like this. I'm not writing set int again and again, I'm just showing you. Or we could actually make a set using an array. Say if I write array plus n, this means that I want to copy n elements of this array into this set and a new set will be formed. I can actually form a set using a vector also. So I could have written as v dot begin v dot end. In this case, if you notice, in vector there might be some elements which are coming again and again, right? So say there are 2 times 2. But when you make a set out of it, that won't be the case and the elements will get sorted. So the size of this set might be lesser than the size of the vector and the elements will get sorted. But if I make a multiset like this, then the size of multiset, that is S, will be same as vector. We can actually make a vector also like this from a set or a multiset. So if I have to write vector of int, say I give the name v, I can just write s dot begin and s dot end. Now, another thing that I want you to think of is that here I have made a set of integers. But since set is a template class, the data type could have been anything. It could have been string or it could even have been a user-defined class. Say I make set of user-defined class ABC that I have made. But set has to sort itself, right? It is a self-balancing binary search tree. So as we insert the elements, it has to sort 2 objects of the class that I am passing. How will it do so? Say I write COMP and I write S. It takes by default less and it sorts in ascending manner. Say I want to sort the integers in descending order instead of ascending order. Then I can pass the comparative function greater int. It basically returns true if the first argument is greater than the second argument. Now, for user-defined classes, you have to override the operator less than. Basically what set does is, it looks for this operator to sort the elements. For integers, strings and all, this is already present, and for user-defined classes, we have to override this operator. There are ways to avoid overriding this operator using lambda functions and functors, but we are not going to discuss that. For now, to form sets of user-defined classes, you can just override this less than operator. Now that we know how to define a set, let's see how to insert, remove or find an element in the set. Since this is not a sequential container, there is no push front, push back, pop front, pop back like in lists and vectors. In fact, there is just insert, emplace and erase. You can just pass the element that you want to insert or remove. What will be the complexities of this insertion or deletion? For that, I again want you to picture the tree. Since it's a BS tree, the complexity to find an element will be log n, and similarly to insert or delete an element will be log n. There are a few functions that work just like vectors and lists for sets and multisets as well. For example, we can check the size using s.size. We can check the max size using s.maxSize. Again, max size has nothing to do with size, but it depends on system or library implementation limitations. We can also clear all the elements using v.clear or check if a set or multiset is empty using s.empty. Also, just like vectors and lists, we have iterators for sets and multisets as well. We have begin pointing to the first element. We have end pointing to the next element after the last element of the set. We have reverse iterators, r begin pointing to the last element, r end pointing to the element after the first element in the reverse direction. And we have the constant iterators corresponding to these iterators. So that's it about sets, guys. These are super important containers. Wherever you think that the elements need to be sorted, while inserting them itself, you can sort them and you can access the elements, insert, remove everything in log n time. Use sets. They are very commonly used in competitive programming. Do let me know your comments, and in our next video we will discuss pairs, map and multimaps. So stay tuned and please don't forget to like, share and subscribe. It will mean a lot to me. Thank you.